Alright, this lesson is about arcs and central angles. First we have to get a little bit of vocabulary out of the way. When we talk about arcs, first of all, an arc is a part of a circle. So for example, if I go from A to B but I'm traveling along the circle, that red curve that I just drew, that's an arc because it's a portion of a circle. There are different kinds of arcs. If you have an arc, well, first of all, let me talk about a semicircle. Of course, the root semi means half, and so a semicircle is half of a circle. So if I talk about an arc that is exactly 1/2 of a circle, like this, that's a semicircle. Now, anything bigger than a semicircle is a major arc. Anything smaller than a semicircle is a minor arc. Now, arcs are measured, they have degrees, just like angles do. And the bottom line, when it comes to the measure of an arc, you know, how many degrees it is, if you look at the angle that's formed at the center of the circle, and it's called a central angle, whatever would be the degrees of that central angle, it's considered to be the same measure of the arc. So for example, say if this turned out to be 50 degrees at this angle right here. Say if this angle AFB, was a 50-degree angle. Then we would say that arc AB was a 50-degree arc as well. So the degree measure of the arc is the same thing as the degree measure of the central angle that it goes with. Okay, so in other words, ask yourself, semicircle, how many degrees is a semicircle arc? You guessed it, a semicircle is always going to be 180 degrees, you know, because the angle that it matches is a 180-degree angle. Okay, so I think that is the background that you need to handle the problems I'm going to be talking about today. So this first part of the lesson, we're supposed to determine whether the given arc is minor or major, or of course a semicircle. Now, you know what, I guess I need to mention one more thing. Here where it says, problem number 1, it says, look, arc AB. And you see here's A and here's B. So if you didn't know any better, you might have a question and say, wait a minute, I could go from A to B that way, and that would be a minor arc if I did it like that. But what if I chose to go from A to B the other way? You know, if I went from A to B, but I went the long way around. Isn't that still an arc from A to B? But if I went that way, it would be a major arc. So how can I answer any of these questions if I could always go either way around? And the answer to that is, can you notice that some of these are written with only 2 letters, and some of these are written with 3 letters? If it's written with only 2 letters, like arc AB, you are supposed to assume that we are talking about the minor arc. If you want to talk about a semicircle or a major arc, you know, if you want to go the long way around, you have to include a 3rd letter to show you that you went the long way around. So basically, as soon as I see that it's just a 2-letter description, you can pretty much immediately know that that is going to be a minor arc. Okay? If I just say arc AB, it means from A to B the short way. If I wanted to talk about going from A to B the long way, I'd have to include one of these extra letters like E, D, or C. You know, for example, if I wanted to go the long way, I'd have to say, everybody look at arc A, E, B, for example. That would be the major arc from A to B the long way. Or if I said, look at arc ADB, or look at arc ACB. All three of these arcs are different names for the same arc, the arc that goes from A to B the long way around. All right, anyway, back to work. Tidy that up a bit. Beg pardon. And now I'm just going to do the odds here, so I'm going to skip around a little bit. Now, arc EAC. So that was a minor arc. So you switch to red. I'm going to go a little bit bigger. Arc EAC, that means from E passing through A and continuing on to C. Yeah, it's important that we stay on the circle the entire time. So that's arc EAC, and that is a semicircle. Okay, if I look at arc CAD, that's from C to A to D. Okay, so arc CAD is going to go from C through A around to D. So that is a major arc because it is bigger than a semicircle. It's more than 180 degrees. Arc BAE, B to A to E. So that is clearly a minor arc because it is less than 180 degrees. It's smaller than a semicircle. Notice that if I wanted to be more efficient with my naming, I didn't have to call it BAE. I could have called it arc BE. And that would have been the same arc. Using the extra A in the middle was unnecessary. Okay, so that's how you do problems like that. Now, moving on down. In this figure, let's see, PR and QS are diameters. Okay, so PR and QS, so these lines go straight across. They are diameters. They're cutting the circle into two semicircles. So that's good to know. Find the measure of the indicated arc. So, look, this is what I want to do. This is what I want to do. I'm only going to really have to do the odds here, but I'm just going to start filling in stuff and see what I get. For example, when I look at these two angles that are across from each other, okay, anytime you have angles that are formed by intersecting lines like this, they're called vertical angles. And maybe you know this, but vertical angles are always equal. So if this is 42 degrees, this is going to be 42 degrees right here. So, okay, that was key. That was pretty crucial. Now, here's something else. We were told that this line, for example, right here, is a diameter. Okay? So that is one straight line through the center of the circle. Now, so you can see that this, let me switch to highlighter mode for a second. I'm hoping you can see that this is a semicircle. Alright, if that's a diameter, then this is a semicircle. So how many degrees did I just highlight in yellow? How many degrees is that? What shall I do with my colors? I hope you can see this. This, of course, would be 180 degrees that I just highlighted in yellow. It's a semicircle. It's 180 degrees. That means all of these angles in here have to add up to 180. So I'm only missing this one pi piece, this one arc and angle. So I should be able to find that very easily by subtracting from 180. So if I take 180 degrees and I do minus 42 and minus 64, and I see what's left, what's left should be this angle over here. So let me just do that on my calculator. Okay, I got 74 degrees. So that tells me that this angle right here, this missing angle, is 74 degrees. All right, in a similar way, I can do the other side. Maybe I'll highlight that once again. So let me just erase all this and that. So I've done this side of the semicircle. But now let's turn our attention to this side of a semicircle. All right, of course, any semicircle is going to be 180 degrees. And again, we're given all of it except for one angle. We're given that this is 42. So all I really need to do is take 180, subtract 42, and that's going to tell me what's left over here. All right, so I believe this is going to be 138 degrees, 180 minus 42. Okay, so now I have found all of the angles that make up this circle. And remember that if I'm asked about the arcs, the arc measures are the same as the central angles that I've just shown you. Okay, so now I'm going to go through the odds and see what I need. What do I need? Okay, let me go back here. So, the measure of arc PQ. So PQ is right here, and I look down and I see, well, that's 42 degrees. The measure of arc TPS. Okay, so TPS, okay, I have to go in that order. So look at this arc. You know what, let me go highlighter mode. TPS, it means I have to start at T, go through P, and go all the way around to S. Alright, I've just highlighted arc TPS, clearly a major arc. So, I mean, I have two choices because see how this is made up of multiple arcs, multiple central angles. I could sit here and add up 64 plus 42 plus 138 plus 42. I can add all those up, and that's going to give me the measure of arc TPS. Or it would be slightly faster to start with the fact that the entire circle is 360 degrees. And arc TPS, shown here in yellow, is almost the whole circle. It's everything except for the 74 degrees that's not included. So I could just take my 360 minus the 74 degrees, and that's going to give me the yellow angle TPS. That turns out to be 286 degrees. Alright, but if you didn't like that subtracting thing, you could add up these four angles and that would be the same thing. Arc RQS, let's take a look at that. Okay, RQS, so from start at R, go through Q, and go to S. That's R to Q to S. You have to go in that order. So again, for me, the quickest way to do this would be to subtract. So I will start with 360 degrees. It's the whole circle except for the 42, so to me that's the quickest thing to do. Okay, so that's going to be like 200, and what's that, 18? Wait, did I say 218? I meant 318. So yeah, so that's going to be 318 degrees. How about arc PQS? Okay, let me start that over. Okay, PQS, from P to Q and then to S. All right, a lot of these major arcs. So this time I'm just going to add. So I can go, 42 plus 138 plus 42. All right, I can just add all these up, and that's going to be my answer. That turns out to be 222. So that's going to be 222 degrees. If you just want to do slightly less typing or writing, you could realize that the 42 and the 138, that's a semicircle. All right, so you really could have just done 180, because from here to here, that's 180 degrees plus 42. And okay, that would be just the same thing. Just a little quicker, just trying to give you all the shortcuts and clues. And finally, Arc PS. Remember, if it's only a 2-letter designation, that means we're going the short way around, the minor arc automatically. So Arc PS, we will definitely do from P to S the shortest way possible. So I'm simply going to add these, the 64 plus the 74. And that is 138. So that's 138 degrees. Okay, so that gives you a feel for how those types of problems work. All right, moving on, let's take a look at number 19. Arc PQ has a measure of 90 degrees. Okay, so we're talking about arc PQ, that's like this, and we're told that that is 90 degrees. Before I even look and see what they're asking me, please understand that remember, the arc measure and the angle measure go together. So that means this angle is a 90-degree angle. Another thing that just jumps out at me immediately, because we're dealing with a circle, I'm always on the lookout for radii. Remember, little vocabulary here. You know that the radius of a circle goes from the center out to the edge of the circle. And the plural of radius is radii. So one radius, but here I have shown 2 radii. And radii are always the same. So if RP is 7, then RQ is also 7. So how about that? So that helps me very much because I'm supposed to find the length of segment PQ. Okay, I'm supposed to find the length of this right here, PQ. So this is a right triangle. If I wanted to do it the long way, because I'm not sure, we've worked, if you followed every video I've ever made, we've done units about special right triangles, where it turns out that this is a 45-degree, a 45, 45, 90 triangle. But just for a moment, let's say you didn't know about the special properties of a 45, 45, 90 triangle. You could do the Pythagorean Theorem. So a squared plus b squared equals c squared. So that's going to be 49 plus 49 is equal to x squared. So that's going to be what? 98 is equal to x squared, and then you could take the square root of both sides. All right, now I'm betting that this is going to turn out to be 7 radical 2. If you put that in your TI-30 XS multi-view calculator. But of course the shortcut is we learned in a previous unit that when you have a 45, 45, 90 triangle like this, it's always going to be leg, leg, and then leg radical 2. So we immediately would know that if this is 7 and this is 7, then this is going to be 7 radical 2 without doing all this work. Watch out for the shortcuts, my friends. All right, number 21. What do we have here? What do we have here, my friends? Well, this is 90 degrees in here, and we know that the entire circle is 360. So if I start with 360 and I take away the 90 degrees, what do I have? 270, right? So that leaves 270 degrees. Okay, now, so that means I've got 270 degrees to be shared equally. So let me do this like here. I've got this 270 degrees to be shared equally between this side and this side. So of course, to figure out how big each part is, I'm going to divide that by 2. So that's giving me 135. So that means this is 135 degrees, and this is 135 degrees. Okay, so you know 135, and I know these would be the same because of the markings. These are both marked with a single line, so I know they're equal. So 135 plus 135 plus 90, that better all add up to 360. Anyways, we are supposed to find the measure of arc AC. So if I go back and do that, you know, arc AC, well, we've done it. You know, arc AC is just this arc right here, and that is 135 degrees. Okay. So 135 degrees, that's the answer. So skipping to 23, because I'm kind of doing all the odds, it's almost the same thing, but we're starting from just this total of 180 degrees. All right, everything over here is kind of part of this semicircle. So I know that's 180 degrees. So if I start with 180 degrees, and then I see this is 90 right here, so if I take away the 90, that's going to leave me with 90. So that leaves me with 90 to be shared equally between this side and this side. So it's a matter of taking that 90 and dividing by 2. All right, and of course 90 divided by 2 is 45. So that means that this must be 45 degrees and this must be 45 degrees. So when they ask me about the measure of arc DAB, okay, I'm gonna have to do some erasing to make this more clear now. So hope you've been paying attention. Okay, so I hope you understand where we got that from. But now, actually, they're asking me about arc DAB. They're asking me about that major arc. Well, of course, this down here, you know, is a semicircle. So this is 100, whoops. This is 180 degrees down here. Okay, so this DAB is 180 degrees plus 45. So I'm doing 180 plus 45. That is 225. So that's why DAB is going to be 225 degrees. All right, good for us. Good for us. Man, how many of these we got to do? All right, 30, going up to 35. So what's next? Number 25. Two diameters of circle T are PQ and RS. Find the given arc measures. Man, they're going to make us draw our own picture. That seems just wrong somehow. But let me zoom in. All right, they're making us draw our own pictures. All right, so I guess we're going to need a circle. So I'm going to draw myself a nice circle here. See what I can do. Okay. All right, two diameters of circle T. So this is circle T. So when they call something circle T, that means that T is the center of the circle. Okay, so if this is circle T, that means that the center is T. So two diameters are PQ and RS. So let's draw a diameter. It's going to be a little tricky. So there's a diameter, sort of. And here comes another diameter. Okay, so those are two diameters, and one is PQ. Okay, so let's see, I'll just call this one PQ, I guess, why not? And the other one is RS, so I'll call this one RS. So, given that information, we're supposed to find the given arc measure. Oh, one more thing. Arc PR is 35 degrees. It's good to know. So that means that this is 35 degrees, which of course means this down here. This angle is also 35 degrees. So finally, we're set up to now answer the question number 25. So we're supposed to find the measure of arc PSR. Okay, so let's go ahead and find all these angles. If this is 35 degrees, then this is 35 degrees. Those are vertical angles. Remember that, for example, this from here to here is a semicircle. Okay, that's 180 degrees. So if this side over here is 35 degrees, I should be able to subtract from 180 to find the other side. So if I go ahead and do 180 minus 35, that'll give me the other side of the semicircle. Okay, so that's going to be 145, right? So this is 145 degrees over here, which means, of course, see how these are vertical angles? So this will also be 145 degrees. All right, let me get rid of some of this extra stuff. So now I have all the angles. So if I'm supposed to find arc PSR, seems a bit much. Okay, PSR goes like this. It goes from P to S all the way around to R. Okay, I think I went too small with it now. Okay, PSR is this arc that I've just highlighted in yellow. So I can either do 360 minus 35, which would be the absolute quickest thing to do. All right, because this yellow, you see it's the whole circle except for the 35. So the quickest thing to do is to do 360 minus 35. So that's going to be what, 325? Yeah, that's 325 degrees. So that is the answer to the question. But if you didn't like that, you could do 145 plus 35 plus 145. You could just add up these three arcs and angles, and that would give you the total, which is the yellow that we're looking for. Okay, all right, are there any more on this picture? Yes. We're supposed to also find the measure of arc PRS. So let's go ahead and do that. What was that? PRS. So if I do that one, let me switch my highlighter again. So arc PRS goes from P through R and around to S. Okay, so just to switch things up, this time I'm going to add. Why not? So again, I could do 360 minus 145, and that would really be the quickest thing to do. But I could also go ahead and do 35 plus 145 plus 35. Okay, I can just add up these three. And that is 215. Okay, so that is the answer to this particular question, 215 degrees. So that's how we do problems like that. Like, all these are like little puzzles. I think they're kind of fun if you set your brain just right to see it as a fun puzzle to do. Anyway, let me zoom back out a little bit better. So just a few more problems. All right, this is another one we have to draw our own picture. Okay, let's just draw our own picture then. Why not? Where am I going to draw this picture? I think I'm going to squeeze it in over here on the right. So here I go. 2 diameters of circle N. Okay, so here is going to be my circle N. And so if this is circle N, that means N is the center of the circle right here in the middle. And I got my 2 diameters, so once again, I probably should have just copied the other picture. Would have been quicker, but I didn't think of it, and now I'm half done. So what are you going to do? What are you going to do? Okay, so my 2 diameters are supposed to be JK. Okay, so here's J and here's K. And the other one's supposed to be LM. So let's see, there's L and there is M. So what about it? What about it? Find the given arc measure if arc JM is 165. So we are given that this is 165 degrees. Well, this is really just like the problem we just did. So if this is 165, well, I should change colors now because now I'm starting to do my work. Kick this up a notch. If this is 165 degrees, that means this is 165 degrees. They're vertical angles. Remember about the semicircle, right? Looking at the semicircle that goes like this, more or less, forgive my spastic drawing. Since this is 180 degrees, I should be able to just subtract from 180 to find the missing piece here. So in other words, if I do 180 minus 165, that should give me this angle right here. So that's just 15 degrees. All right, so this is 15 degrees, which means this is 15 degrees. Now I'm ready to answer any question that they throw at me. But let me clean this up a bit first. So I'm supposed to find arc JMK. So JMK is this arc right here from J to M to K. Well, that's easy because that's a semicircle. So arc JMK is just 180 degrees. Okay. What about arc KLM? All right, arc KLM, I lost my, yeah, it's going to go from K through L all the way around to M. So I'm going to do it by subtracting this time because that's the quickest way. that's gonna, if I do 360, which is the whole circle, minus 15. Okay, that should give me the answer here. All right, because it's the whole circle except for 15 degrees. So that's 345 degrees. Okay, kabam. That's how you do that. All right. Oh, look, they were nice enough to give us the picture this time. So for number 33, before I even look and see what they're even asking me for, I just can't help it. I want to fill in this missing piece just because I can. Don't you ever just feel that way? Just you want to do something just because you can? I feel that way all the time. Lost my place. Yeah, semicircle, once again. Can you see that? This is a semicircle. So that's 180 degrees out there. This is a total of 180 degrees. And I've got everything except for this piece. So if I sit here and go, you know, 180 minus 96 minus 42, you know, that should give me this missing piece over here. And it turns out to be another 42 degrees. So now I can answer the questions. What are they asking me? Tell whether the given arcs are congruent. So we're supposed to tell, is arc AB congruent to arc CD? Oh, look, they're both 42 degrees. So that's going to be a yes. All right, and we have arrived at the last problem of this assignment. And I guess once again we're supposed to tell if these are congruent or not. Are these still the same directions? All right, they don't look congruent, but sometimes drawings are not to scale. So again, with the concept of the semicircle, we're dealing with the semicircle here. And this is 90 and that's 30, so I could simply do the 180 minus 90 and minus 30, and whatever's left should be this angle right here. Okay, and that is going to be 60. So, okay, well, I guess I need to pay special attention to what these two angles actually are. So that is 60 degrees, which is good to know. Of course, this whole big thing down here is 180. So the two angles, or arcs, that we're being asked about are arc STV. So here's arc STV. And we're being asked, is that the same as arc UVT? Okay, and just switching colors for a second. Arc UVT is this arc right here, from U to V to T. All right, the yellow arc and the blue arc, we're being asked if those are the same. And they're clearly not the same, but let's follow through. The blue one here is 60 plus 90. So that's going to be 150 degrees. And then the yellow arc is 30 plus 90. So that's going to be 120 degrees. Okay, so clearly those are not congruent. So we would simply say no. All right, and so that is a little introduction to how we work with arcs and central angles. The take-home lessons are that as far as the degrees go, the measure of an arc is the same as the measure of the central angle. And a semicircle is half of a circle, and anything bigger than a semicircle is a major arc, and anything smaller than a semicircle is a minor arc. And remember that if they just give you a two-letter designation, like BE, that automatically means the short way around, the minor arc from B to E. If you want to do a major arc, the long way around, you have to include a third letter to tell you to go the long way around. Here endeth the lesson. If this lesson was helpful to you in any way, and I apologize that this was a really long lesson, 40 minutes is a long time. But if you found this helpful, please go ahead and give me a thumbs up, hit that like button, and that will help my channel grow and help me reach others. I want to help everybody, and I will really appreciate it. Take care. I will see you on the next video.